All right, so for this lesson, we are going to be talking specifically about factoring with a difference of squares. So this is one of those special versions of the factoring trinomials that we just did. It just has its own name. So when we take a look, the first thing we are going to do is multiplying binomials using the table method or using the FOIL method. We have primarily just been using this method here in class. So when I take a look at these, I'm going to have to make sure that when I'm doing it, I multiply everything through accordingly. Same thing we've been learning about before. We can see that this very much looks like the form that will multiply together to give me a simple trinomial. So here I have x times x is going to give me x squared. X times positive 5 is going to give me positive 5x. Negative 5 times x gives me negative 5x. Negative 5 times positive 5 is going to give me negative 25. I can simplify my like terms, and this is going to give me x squared. Those both go away, minus 25 as my final term. If I take a look at the square method, we haven't done this one much, but we can do it now. It's essentially taking a look, and I'm going to write 1 on top and 1 down the side. And I'm essentially forming a square when I do that. So if I take a look, x times x gives me x squared. X times positive 3 is going to give me positive 3x. X times negative 3 is going to give me negative 3x. And negative 3 times negative 3, or positive 3, is going to give me negative 9. I can look and see that if I just write these out, I will get x squared plus 3x minus 3x minus 9. If I simplify these terms down, I will get x squared minus 9 because positive 3x minus 3x is 0x. This form is what we call a difference of squares. So you'll notice it is or originally starts off as the simple polynomial or the simple trinomial. But here, there's no x in the middle. It's just x squared and then c. So there's no bx. For this to count as a difference of squares as well, this second value, our c value, must be able to be square rooted. So for instance, if I take a look here, I have the square root of 16 is going to equal 4. So I know that it will be x plus 4, x minus 4. If I take a look here, the square root of 25 is 5. So I know it will be x plus 5, x minus 5. Essentially, a formula that you can use for this is x squared plus c is equal to x plus, or sorry, that should be a minus. It will always end up being minus x plus the square root of c times x minus the square root of c. Square root of 100 is 10, so it will be x plus 10, x minus 10. Here, I'm going to have to square root both numbers, and I will end up getting square root of 9 is 3, square root of 25 is 5. So I will end up getting 3x minus 5 times 3x plus 5. So if you're taking a look at these, there's a couple different rules that we have for factoring a difference of squares. You must be subtracting two terms, and they both must have numbers that are evenly divisible by 3. First one is That means that we must have a form of x squared minus a coefficient. And 2 is that the numbers must evenly square root. So far, this has worked for all of the values that we did. If it didn't work, we would not call it an even square. Or sorry, we would not be able to use difference of squares here. So difference of squares is just going to be a polynomial in which a square term is subtracted from another square term. So if I take a look here, I can see automatically negative, negative, positive, negative. I cannot use difference of squares there. That is not how you spell value. If I take a look at this one, that easily square roots to 12. That easily square roots to 6. That does not square root. So this one does not. This 5 doesn't easily square root. If I take a look at D, 16 square rooted gives me 4. 121 square rooted gives me 11. I have my negative. So yes, I can factor A and I can factor D using difference of squares. If I look at A, it's going to give me x plus 12, x minus 12. If I look at D, it's going to give me 4x minus 11 times 4x plus 11. Awesome, and that's everything for this lesson.